Mensuration. You have learnt about finding the areas of different geometrical shapes such as a rectangle, square, quadrilateral, trapezium, parallelogram, and so on. Now let us discuss about finding the areas of polygons. Look at this window. This window has a shape of a polygon. What would be the size of the tinted glass so as to fit in the window? Look at this table. The shape of the top of this table is polygonal. How would you paint the top of the table? To do these tasks, you have to answer the following questions. How to find the area of the surface of the window? How much paint is required to paint the tabletop? While finding the area of a quadrilateral, we split the quadrilateral into triangles and then find its area. Similar methods can be used to find the area of a polygon. Let us consider a pentagon. We can split the pentagon in different ways as shown here. Let us see how will we get the area of the pentagon if we split the pentagon as shown in the first figure. Here, by the construction of two diagonals AC and AD, the pentagon ABCDE is divided into three parts. Then, the area of the pentagon is equal to sum of the areas of triangle ABC, triangle ACD, and triangle AED. Thus, if we are able to find the areas of these triangles, we can find the area of the pentagon. Let's now calculate the area of the pentagon given in the figure with the help of the given dimensions. Here the area of the pentagon PQRST is equal to the sum of the areas of triangle PQT, triangle TQR, and triangle STR. Recall that the area of a triangle is equal to half the product of base and height. By substituting the values in this formula, we can obtain the area of the pentagon. Area of the given pentagon is equal to 52 square units. If we split the pentagon, as in the second diagram, how will we find the area? In this case, by constructing one diagonal AD and two perpendiculars BF and CG on it, the pentagon ABCDE is divided into four parts. So, area of ABCDE is equal to the sum of the areas of right angle triangle AFB, trapezium BFGC, right angle triangle CGD, and triangle AED. Let's now calculate the area of the pentagon given in the figure with the help of the given dimensions. Here, area of the pentagon ABCDE is equal to area of the trapezium DEFG plus area of right angle triangle AEF plus area of right angle triangle CDG plus area of triangle ABC. Now, using the area formulae, let's calculate the area of the trapezium and the triangles. Let us substitute the values from the figure. Simplifying, we get the area of the pentagon as 36 square units. Let us now see if we have a regular hexagon. How to find the area? There is a regular hexagon MNOPQR of sides 5 centimeter. We can split this hexagon in two different ways as shown here. In the first case, since it is a regular hexagon, by drawing NQ, we can divide the hexagon into two congruent trapeziums. Area of hexagon MNOPQR is equal to the sum of the areas of trapezium MNQR and trapezium NOPQ. As the two trapeziums MNQR and NOPQ are congruent, their areas are equal. Thus, the area of hexagon MNOPQR is 2 times the area of trapezium MNQR. Suppose ML is equal to 4.3 units. Area of the trapezium is equal to half the product of the sum of the parallel sides and the distance between the parallel lines. Let us substitute the values. By simplifying, we get the area of the hexagon MNOPQR as 64.5 square units. Now let us use the second method. Therefore, the area of hexagon MNOPQR is equal to the sum of the areas of congruent triangles MNO and PQR and rectangle MOPR. The above equation can be further simplified as the area of hexagon equal to the sum of twice the area of triangle MNO and the area of rectangle MOPR. Now, if all the dimensions in the hexagon are given as shown, then we can find the area of the hexagon. Recall that area of a triangle is equal to half the product of base and height, and area of a rectangle is equal to the product of its length and breadth. Now, substituting the values, we get area of the hexagon as 64.5 square units. Observe that the area of the hexagon remains the same, no matter in which way the hexagon is divided. Let us summarize what we have learned. Area of a pentagon can be found either by splitting it into triangles or by splitting into triangle and quadrilateral. Area of a regular hexagon can be found either by splitting it into trapeziums or by splitting into triangles and rectangle.